Griffith has had a strong history of alternative energy research or renewable energy research for some time, and there were almost, if you like, accidental conversations going on in parallel between some of the work that our staff were doing on hydrogen storage as a modality for storing energy and the opportunities for doing something exciting in the renewable energy space around an education investment fund building. So we put the two together and said, well, why wouldn't we attempt to do the world's first large-scale building that incorporated solar energy but utilised low-pressure hydrogen storage as the storage modality.
It was really a matter of planets aligning. We were master planning the campus, seeking ingredients that would invigorate it, and we talked to the Vice-Chancellor and thought, hey, there's a chance here to do a new building that tests this technology, showcases it as well, but the other thing is to create a building that kind of really changes the direction of the university architecturally and for the experience of students.
The building is a research project in itself. So it's a social research project in terms of the way that we bring together discipline conversations around sustainability, ranging from engineering, environmental science, business, sustainability of all forms of energy use. But it's also a living laboratory. The energy use and distribution within the building is mapped, is visible through a status panel that we use as part of the public display, but it's also used as a research tool for our renewable energy research program.
The intent of the building is primarily to show how we can capture solar energy in areas where there's no electricity grid and stay off-grid through all sorts of bad weather. This hasn't been done before. We're the first to do this on any scale, and perhaps the first to do it ever, where energy storage has been built into the design of the building from day one. And our energy storage is primarily hydrogen storage, and that's even more remarkable.
The other components are all relatively standard off-the-shelf systems. The difference here is that they have never been integrated into a project in quite this way. And the challenge for the engineering teams has not been in the individual componentry, but in bringing the system together in an integrated fashion. This is part of the know-how that we can actually share as part of the development of this project.
The real art of this building is in bringing together technology with a design for people to work in that's really different than the way they've been doing it previously.
One of the design briefs was to bring together disciplines in a way that maximised the chances that people would collaborate across discipline boundaries. And that's expressed in some of the design features in the building, particularly how the outside spaces, the breezeways and the stairwells are actually part of the mixing space for people who are using the building.
People are working perhaps at one end and someone else is working at the other end and may never need to meet. And that's where the idea that the verandas that became the circulation spine along the south face have collaboration zones within them, and that allows the people to come out of their little cocoons, meet together in these kind of spaces. And there are different spaces. Some are very open to the elements, and other spaces are more enclosed element at the end with kitchens and cafe type facilities within them. So they're really there to encourage people just to come out and say, hey, what are you doing?
We've installed sensors to detect almost everything you can think of that's to do with how a building operates and demonstrating how it's working, how well it's working, and understanding how it's able to stay off-grid. That includes air temperature sensors and airflow sensors, solar electricity flows, everything you can think of to do with electricity, hydrogen flows, rate of generation of hydrogen, rate of consumption of hydrogen, the amount of hydrogen in storage, the pressure of the hydrogen gas, and so on. Almost everything you can imagine. It will provide a very rich stream of data for scientists to use for research projects on how to design such installations and ways to use renewable energy.
We wanted access to this building to be viewed as a privilege, and we've managed that through headquartering our key environmental or sustainability research institutes in the building. And these are deliberate showcase tenants for this iconic university building, and they reflect a research history that's 40 years old. We've had a history of investment and commitment to sustainability generally, and particularly environmental science. And those significant research areas of the university are all headquartered in this building.
We're still learning how to operate the building in its most effective mode, and in fact we're engaged in research to do exactly that. Students are working on projects that will ultimately help us to decide the best way to use all the components in the building for the best outcome, that is staying off-grid for the longest time. And so we're looking through the very many possibilities of how to engage all of these components together to find the best way for us. That's the part of the project that's going to take longest to get right, because nobody's done this as far as we know.
Universities have both the opportunity but also the obligation to actually push the boundaries in relation to developmental projects. A project such as this that utilises intellectual property from within the university, good design, and addresses issues of international concern is, in our view, exactly the sort of project that a university like Griffith, with its focus on sustainability and sustainable design, should be engaged in for the public good.